Hello everybody. So in this video, we're going to doing a bit of a breakdown on the rig hierarchy for any Hive rig. Now we're not going to go into the individual components and how they're structured, but what we're going to look at is just the high level implementations of just how every component is going to be laid out no matter what. That way, when you are going through the rig, doing things like troubleshooting or just trying to find things, you know what you're looking at, you know what things stand for, and you have a general idea of the purpose of certain types of nodes. So the first node we're going to look at is the root node. It's for organization purposes. But you might start seeing this very common suffix, and that is underscore HRC. That stands for hierarchy. You might be used to this term called group instead. This is the same thing. Its sole purpose is to group up your hierarchy and do nothing else but organize your scene. It has zero transforms, so it's an identity matrix on the transformation, and all of these channels, the transformation is always going to be locked. So you cannot screw around with it, the animator can't play around with it, can't break it. There are potentially exceptions to that rule, but basically, for 99.99% of the cases, that's always going to be essentially locked off. The next node we're going to look at is the first child, which is going to be the component layer. Layers is something that we dive into in probably one of the next couple of videos, which is going to be around the meta system and how the whole entire brain of Hive works. But the component layer is a collection of components. It just manages component instances themselves. Now, all of this correlates to the API as well, so all the terms you'll find here actually match up. So in terms of understanding things, you learn one thing and you learn it all. Next one is the deform layer. The deform layer is, well, it's all about deformation, but it's about global deformation. The only exception to that is joints, where all your joints for your rig, for your skinning, to be more accurate, is always going to be in the deform layer at the top of your component. This may also contain things like global deformers, like if you have a lattice deformer that you want to apply within your build scripts, this is a place where you would actually parent those lattice deformers to make sure it's sitting somewhere reasonably safe. And this is kind of like the tagging system and so on. So if you want to tag your deformers as part of it, so you can later retrieve those deformers for things like deletion or for changing values and so on when you're writing animation tools or rigging tools, this is a place to do it. The GeoHRC is your essentially geo group. It's always going to contain your geometry. So if you're a rigger and you've got geometry in the scene, all you want to do is parent all your geometry into GeoHRC, and it'd be the same thing as parenting it to a geo group. The next thing is the inside the component layer, where we start getting into how components are laid out. I'm just going to jump into the leg left, HRC. As I said, HRC is going to be used quite a bit. It's all about just organization. All your components are going to be completely listed here, and then what you've got underneath this is going to be your deform layer, your input layer, your output layer, your guide layer, and your rig layer. Do note that I've got the rig build mode activated right now. See the previous video for the build modes and the explanation of those. But now I've got the rig mode open, I can see everything. So it gives you a better way of troubleshooting your actual animation rig and your guide rig, so you can do things like diffing to make sure everything is kind of lining up between your guides and your rig, including alignments and so on. Now, the first one is the deform layer. In most of our rigs right now, we have nothing inside the DAG for your deform layer, because that's all sitting inside the top root node of your rig, which is where your skeleton is. But this can also contain lattice deformers and anything else you want to contain just for that component. So if you have a lattice deformer that's just affecting the leg, then you would put that inside here. The only way you would not do this is when you're doing things like build scripts, where you would put it inside the top level deform layer. Now, input and output layer. These are really, really important. They correspond to the connections between your components. You can basically think of the input and output layer as a promise. An input layer promises that every component that's going to control your component, like your leg component, is going to always attach it to the input node. The only exception at this current stage may just end up being your space switching, but we do our best to make sure that there is an input layer and an output layer for every potential control that you might be able to connect to. We'll get into that when you start working with custom components. In terms of the input layer, we only currently support transforms. We did at one point have attributes as well, so you can basically have all your world matrices inside of attributes instead. However, that becomes a little bit more complicated when it comes to management. There's a lot more involved, and typically it would require manual labor instead of doing it through a UI. There is ways of doing it through UI, it's just more complex. So this is the kind of like the faster and easier way, more intuitive way. So when you create a constraint, for example, between in the UI here, obviously it's not in guide mode, but if you set the parent of a component, what you're doing is creating a constraint between the output of the arm here to the input to, say, the fingers, because you're constraining the fingers. That's all you're really doing. The output layer is the opposite. It just outputs transforms of your rig. So for example, I've got the upper, which is the upper leg. If I go inside this and go to the knee, it's where your knee joint is, and your twists are the same, right? So if I go between each of the twists, that's where it is. And this will contain your entire world transformation. So it's your final output. And this would be the same for your deformation skeleton. The next layer is going to be the guide layer. This makes sense quite easily. You have the root guide, which is always going to be, if I just go back to guides for a moment, you have the yellow circles or spheres, which are basically your guides, and anything that's, you might have crosshairs and so on, or boxes in different colors. That's going to be essentially your pivot point. The red boxes are the root guide. Now, this has no direct correlation to your actual rig itself. It's mostly just a container to say, hey, just group my component up, all my guides. So if I do have multiple root guides like the upper and the up vector, I can group them under something if I can. Easy manipulation for the user. Now, inside here, you end up having more guides as children. But the other important one is all these root guide shapes. These are your actual animation controls. Now, this all goes down to serialization, and that's a whole dedicated video by itself. But guide shapes are your actual animation controls. They get serialized and then deserialized when you build the rig. And when you go back to rig, you're essentially deserializing from the metadata to reconstruct the guide if the guide doesn't exist. You then have annotations. That's a little bit of a bug I just found. Great, fantastic. I love bugs. That should be inside the annotation group. The annotation is just the curves or lines between the individual guides. So it's from the parent guide to the child guide, just so you can see kind of the direction of your guides and how that's laid out. Now if we go and just build the rig, so that we have the rig layer. So between builds, different layers will get built and deleted depending on the purpose. The input and output layer will not get deleted unless your deform layer gets deleted, because that has your kind of deformation and input-output kind of state. The rig layer, everything underneath here is kind of irrelevant. How you structure things is completely independent. And me personally as a rigger, I don't really care how it's laid out once you're inside here, because it's very particular to that component and so on, depending on what you're really doing, and it can get more complex as you go along. What's really important is how the kind of top level structure of the component is. In this case, we have a single root node corresponding to your component. Then we have the individual Hive layers. And then inside that, it's kind of irrelevant on how you organize it. But the general idea in terms of names here is you have the parent space with the legs and the arms. The parent space is where your spine sits. This is actually where your parent component is. So even if you parent this to, like, say, the leg to the arm, for example, it will have the parent space will be the arm, right? So this allows for the IK, FK joints, which and the controls, to have the same space as the parent joint of your component. So the leg is parented to the spine, for example. For the IK and FK blending, it needs to be in the same space, local space. That way, when you blend it together, it all ends up being the same. There's ways around that by going blending in world space and then converting into local space, but it's a little more of a hassle doing it that way. So in our case, it's less complex if you just have a single root node, which is basically the parent space. And if you have a look into the node editor, you'll find that it's just a matrix, world matrix, going into the offset parent matrix of the transform. And that comes from the leg upper in, and then because that's the input, remember, everything inside your rig layer is meant to get connected to your input layer. That's like a promise, remember? So it promises that everything you do is always going to be attached to your input layer. If your input layer doesn't have it, your rig doesn't work. And that's kind of it. Like, there's not too much. I'm not going to go into how everything is designed like Bendy. Bendy's got a lot more going on in terms of coordinate spaces, how it converts everything, how it does with angles, and so on. But the main idea is every component has the same top-level structure, the root node, then the layers, and even the rig itself is the same structure, the root node, and then you have the layers. So then you have each layer then has its own way of organizing something, and how all the metadata works is typically the same as well. And that's it. There's not much else. And what we'll do most likely in the next video is get into the meta system, which is the brain of Hive. And it's a reasonably chunky and detailed deep dive into Hive. So I'll see you in the next video.